Chain of thought or not to chain of thought? Chain of thought helps mainly on math and symbolic reasoning. In this video, we will discover how these researchers compiled 100 plus AI papers on chain of thought and what they concluded from them. And they also ran their own experiments on many different models. So let's dive. This paper mainly claims that chain of thought only helps in tasks that require mathematics or some kind of reasoning with steps. Usually some tasks that have sign equal in them. Usually those kind of tasks will benefit from chain of thought and other tasks will not. Because sign equals indicates that there is some kind of mathematical or logical operations, and chain of thought will help the AI just follow the order and not get confused because there is a bunch of calculations it needs to do or steps it needs to do. So one of the things they did is analyze more than 100 other papers about chain of thought, and here we can see on this image 0 is indicating the direct answering without chain of thought, and these dots, if they are over the 0, that means chain of thought improved for this particular case, and under the 0, chain of thought worsened in comparison to the answer given by direct answering without chain of thought. So we can see that here in mathematics, logical reasoning, and algorithms, usually it's shifted to the right. So usually in these three fields, there is a big improvement. And this gray background shows the distribution. So this gray background is shifted to the right, to the positive side, meaning that there is improvement over direct answering. But then in all of these other fields, we can see that this distribution is around center, so there is no improvement with chain of thought. We see that a lot of the examples, for example, here in text classification, it's actually worse with chain of thought for some reason. We get worse examples. And every other category seems that chain of thought does not improve or worsen the results. And here we can see their experiments that they did. So here the blue line is zero shot direct answer, and a yellow line is 0 shot chain of thought. So we can only see that common sense, soft reasoning, direct answer, and chain of thought have same results. Knowledge almost same as well. Symbolic reasoning, chain of thought has better results, and the best improvement is mathematics. So they hypothesized that this is because it's just that mathematics and symbolic reasoning require a lot of steps, and AI can get confused and miss some steps if it tries to directly answer, and chain of thought helps only in these situations like mathematics. If we scroll down, chain of thought only helps substantially on problems requiring mathematical, logical, or algorithmic reasoning. As much as 95% of the total performance gain from chain of thought on MMLU is attributed to questions containing equal sign in the question or generated output. That means that all of the improvement is in questions that contain equal sign, and equal sign is contained in mathematics or algorithmic logical reasoning that contains these logical notations and steps. So all of the improvements of chain of thought is in those kind of questions. They also mentioned that in these categories where chain of thought helps a lot, like mathematics or logic reasoning coding, there are already tools that AI can use. So even in these categories, chain of thought is maybe not so useful, because with tools, AI will do a lot better if it can use Wolfram Alpha or something to calculate mathematics than to use the chain of thought. So they state here that chain of thought is just a waste of resources for most of the problems, because first of all, a lot of the problems it doesn't even help with except mathematics and similar, and then for those kind of problems you already have tools. So chain of thought should be used in very specific scenarios and not everywhere. And for example, Llama models and GPT are using chain of thought by default, but this paper claims that this might not be useful or good. It could just be a waste of resources. They also say that in the future there can be more research on models that are more heavily fine-tuned to use chain of thought. Future work can explore how intermediate computation can be better used to solve challenging problems outside of the math and symbolic reasoning domains. This is probably what the new O1 by OpenAI is using, this intermediate reasoning. Further below, they explain how they collected these 100 plus papers that they compiled into this one research, so you can read that. Here we can see the image that actually shows the direct answering versus chain of thought answering. And this red line is the average improvement of chain of thought. But this red line is moved here mainly by these like mathematics, logical reasoning, and symbolic ones. So we can see that on this black line, all of the distributions are matching the peak. So which means like there is no improvement. But here on the mathematics, we see that these distributions are shifted to the right in comparison to the black line. That means that this is improved by chain of thought. And here on the side, they highlighted some exceptions to this rule. For example, these data sets that achieved big improvements. They explained that a lot of these also contain some kind of logical steps or reasoning, and so they benefit from chain of thought, even though they are not in the mathematics or symbolics algorithms class. And they also say that some of these are proprietary and closed, so they don't know what exactly the data contains. And also they mentioned that some of these might just be an exception, that some of these might not require logical steps, but still somehow benefit from chain of thought for some reason that they couldn't explain, that I didn't see them explaining in this paper. So I think they couldn't figure it out. Down below, we can see their experiments as well, besides the papers they accumulated and analyzed. So here we performed a series of experiments on 20 datasets across 14 models in both zero-shot and few-shot setting to compare performance. Let's take a look at these graphs. So first, this green one, we can see common sense, knowledge, soft reasoning, symbolic, and mathematical categories. And these bars show the improvement with chain of thought over the direct answering. And we can see that the most improvement is happening in mathematical questions and in symbolic questions. And soft reasoning, knowledge, and common sense, which are basically knowledge is, I think, a deep expertise in areas it's like what's written in encyclopedia books. And then common sense is like if you put a glass of water on river and stuff like that, that doesn't have like agreed upon way to solve them, like mathematics has agreed upon way to solve mathematical problems. And then let's take a look at these right graphs, not left graphs. So here we can see a list of benchmarks, and these benchmarks to the right are mathematical logic reasoning benchmarks, while towards the left we go more towards common sense and like knowledge in general questions. So here we can see GPT-4o improving mainly on mathematics, same for Llama. This is average of all of the models they tested. So this is Qwen, Llama, and Claude Sonnet. We can see that all of the improvements from chain of thought comes from mathematical and algorithmic benchmarks datasets on the right. They also claim, for example, here in MMLU, there is some kind of improvement, and they claim that even here, the improvement comes from questions that are that require mathematics step-by-step algorithmic thinking. This graph is also very interesting. Here you can see these different models, AI models, and you can see they divided the questions, the data testing questions, into ones that have equal sign and ones that don't have equal sign, indicating that those that have the equal sign are most likely related to mathematics or symbolic reasoning, and those that don't have are general questions and other stuff. And here we can see that all of the improvements comes from data that doesn't have equal. So that has equal. You see, MMLU Pro with equal and MMLU with equal. those are these lighter crossed bars, and we see that those are actually getting improved. And these full color bars, those are very tiny here, so they are actually so these are without, so these are common questions, so they are not getting improved by chain of thought. So these data points that don't have equal are not getting improved by chain of thought. That's the main point of this paper. For more papers, check out my channel, and I'm gonna be creating more of these videos on different papers. See you in the next video.